In this next video, we're moving up from having a radical equal to a constant to a radical equal to a radical, and then lastly here we're going to have a radical equal to a variable. And so to solve these, it's absolutely the same. Step number one, you're going to isolate your radical. Step number two, you're going to apply your power rule. So the power rule is that you square both sides. So if I have the square root of x plus 3 all squared, that's just x plus 3. Now careful. X plus 1 all squared. Now we have this plus 1. When you square something, it means multiply by itself. This is x plus 1 times x plus 1. That gives you x times x is x squared, plus x times 1 is 1x, plus 1x, plus 1 times 1 is 1. I'm left with a quadratic equation. To solve a quadratic equation, you have to use the zero factor property, which means step number one, you're going to set it equal to 0. So I'm going to subtract x and subtract 3 from both sides. I would end up with 0 equals x squared plus x minus 2. Now that it's equal to 0, I can factor. So I'm looking for two numbers that multiply to give me negative 2 and add to give me positive 1. That's positive 2 and negative 1. I've got x plus 2, x minus 1. Again, if you're using the AC method, just go through, split up your middle term, and you'll get to here. Now that I've set it equal to 0 and I've factored, now I'm going to set each factor equal to 0 and solve. So I've got x plus 2 equal to 0 and x minus 1 equal to 0. So my proposed solutions are negative 2 and positive 1. When I have a proposed solution, I always have to check. So into my original equation, negative 2 plus 3, will that equal negative 2 plus 1? Right here on the right-hand side, I know that I'm trying to make a radical equal to a negative number. I can reject this solution right now. If I keep going, I've got the square root of 1, which is 1, and it's not going to work. So this solution here is going to get rejected. This is not a true solution. It's an extraneous root. Let's try positive 1. So we've got the square root of 1 plus 3. Does that equal 1 plus 1? We're off to a good start. It's equal to 2. This is the square root of 4, which is 2. This one's good. So the solution to this question is just 1. For the next one, step number 1, always isolate your radical. So I have a radical on the left-hand side. I have to get rid of this minus 1. So I'm going to add 1 to each side. I've now got the square root of 1 minus 2x minus x squared equals x plus 1. Now that I have my isolated radical, I can apply my power rule. You can pause the video now. Okay, so this is going to continue just like this one did, and you can give this one a go. Applying the power rule, you're going to square both sides. The square of a square root goes away. And then here I've got x plus 1 all squared. Now again, that means x plus 1 times x plus 1. X squared plus x plus x plus 1. I'm going to isolate my, not isolate, sorry. I'm going to notice that this is a quadratic equation, and so I'm going to make it equal to 0. I'm going to add x squared, I'm going to add 2x, and I'm going to subtract 1. 0 on the left is equal to 2x squared plus 4x, and then plus 0. When you're solving a quadratic equation, you have to use the zero factor property. I've set it equal to 0, now I need to factor. Always try the greatest common factor first. In fact, I notice that I can take a 2x out of both of these terms. I'm left with x plus 2. Now that you've set it equal to 0 and you've factored, now you're going to set each factor equal to 0. Solving for x, I end up with x equals 0. Solving for x, I get x equals negative 2. Now again, these are proposed solutions. I have to check them into my original equation. When I check, I've got the square root of 1 minus 2 times 0 minus 0 squared minus 1. Does that equal x? Sorry, not x. We're putting x as 0. 0. So we check. This is the square root of 1 minus 0 minus 0, so the square root of 1 minus 1, which is 0. Good. Then we check negative 2. We've got 1 minus 2 times negative 2 minus negative 2 all squared minus 1. Does that equal negative 2? Now right away I can see equal to a negative. I know I'm going to reject this solution, but if you keep going, you'll also notice that. So this is 1 plus 4 is 5, minus 4 is 1, minus 1 is 0. This did not work, so I have to reject the negative 2 solution, and I'm going to accept the 0. So my only solution to this question is 0. So now when you look at your homework, you are more than welcome to keep going all the way to 35 in the questions.